Hello, Grid 6. Today we're in my kitchen because this experiment requires a burner. This experiment requires a stove, or a hot plate if you have one, but I don't. It also means I haven't been able to plug in my nice microphone, so I apologize if the sound quality on this isn't as good as it usually is. Anyway, for today's experiment, we're going to be observing the difference between the pressure inside a enclosed heated space and outside. And we're going to need a few things for this. One of those things is an empty soda can, or in this case it's an energy drink can because I use a soda stream and don't have soda cans very much. But we've got an empty can. We also have a bowl of ice water. Yes, there are ice cubes in it. This is actually just straight up ice water. It's full about 2/3 of the way up. You don't want it all the way full because we're going to be putting more things in it. The last thing that we're going to need, just for safety's sake, because we are going to be working with a stovetop here, is things so that we're not burning ourselves. In this case, that is tongs. And I'm also going to be wearing gloves while I do this, just in case there's any splashback on me to help protect myself. You can see I've also got goggles on, just in case. Likely won't need them for this, but it's a good idea to have them. Alright. Now, what we're going to do is we're going to put a little bit of water in this can. We're going to heat it up until it's boiling. And then we're going to have a lot of trapped, very hot air in here, and a very cold bath to put it directly in. So we're going to do exactly that. I'm going to put a little bit of water in here, about a tablespoon, not very much at all. Then we're going to put it directly on a burner and wait for it to start boiling. I'll be right back when I've got that ready to go. Okay, in the time that I was gone, I've put about a tablespoon of water in this can. And I've got it on the burner. The burner's on maximum right now. It is boiling as hot as it's going to boil. So we're going to give it a moment, because until it's boiling, it's not ready. When I start to see steam escaping from this hole, and I can hear boiling going on inside the can, we'll know it's ready. So I'm going to pause the recording until that happens, because you don't want to sit here watching water boil, right? Okay, you might be able to hear something coming from this can. At this point, we are steaming, but we are not yet at a full-on boil. So I am going to point something out before I move on. Now this is with my gloved hand in tongs. I'm not touching it directly. But if I press in a little bit on the side of this can, I can feel it pressing back at me. You might be able to hear the boiling now. This is already exerting a lot of pressure outwards. The air inside the can is pressing out, and some of it's escaping from the top. It's now fully boiling as well, so I'm going to put on my second glove, turn off the burner, and it's time for this thing to take a bath. Now, the thing that we're trying to observe here is the difference between the air inside the can, now that is very hot, you can see the steam coming out of it, and the effect of the cold ice water bath we're about to put it in. Now I'm going to put it in with the opening facing down. It's going to be pushing directly down into the water. To do that, I'm going to hold my tongs like this and come at it from the bottom. I'm going to grip it very securely, make sure I've got a good hold on it, and then I'm going to quickly as possible flip it upside down into the bowl. So here we go. So get a good hold on there. Give it a test before you do anything. You want to make sure you've really got it. But don't press so hard that you're going to crush the can. And here we go. See, I didn't need to press at all to crush the can. That just happened completely naturally. Now, one thing about this is that the can is no longer empty. In fact, if I pick it up, a ton of cold water shot up inside the can, even though the actual can itself has completely imploded. Now that cold water flew up into the can, even though the can did not maintain its shape. The can got smaller, but the water still wanted to fill it. Now, as usual, in a recorded science experiment, I'm not going to go too deep into the why of this right now. The why is for you to investigate a little bit, and we will discuss it in class. But for right now, that's a pretty drastic change. And if you want to do this at home, please make sure there's an adult with you and you're being as safe as possible. This is not one to do unsupervised, guys. Okay? All right. Well, I guess I'll hold this can up for you real quick so that you can take a look at it for your own observations. Should be cool enough to touch now that it's been sitting in ice water for a few seconds, but just in case, I'll leave my gloves on. Here is our can, post-water bath. And the ice cubes have now melted out of this bowl, but that might also just be because it's sitting right next to the stove. All right, that's it. Thanks, grade 6. Cheers.